the carburetor, we have the float bulb, always topped off with gasoline thanks to the action of the float and the fuel pump. As the fuel level drops, the float opens the valve to raise it back up. In the upper part of the carburetor, we have the jet needle, the vacuum piston or slide, and the diaphragm. The whole assembly is kept in place by a spring. Then we have the butterfly, controlled directly by the throttle cable. And finally, we have the pilot jet and the main jet, both feeding the two fuel circuits inside the carburetor. Last but not least, the fuel mixture adjustment screw. Now, how does it work? In idle condition, the fuel is sucked out of the fuel bowl through the pilot jet and is mixed in with the air before going into the cylinder. The whole process is powered by the low-pressure vacuum that the piston creates inside the cylinder. When we twist the throttle, we directly affect the butterfly valve that opens up. Now the low pressure is also starting to affect the top vacuum chamber. The diaphragm is suctioned up, and with it, the slide and the jet needle are raised. As the jet needle is raised, its tapered shape allows for more and more fuel to be suctioned through the main jet. By the same token, as the slide opens, more air is let through the carburetor, proportionally to the quantity of fuel. Since we're at it, let's see what happens when we pull the choke knob. It opens an additional stream of fuel straight into the cylinder, enriching the mix for an easy start with a cold engine. But let's get back to the idle circuit so we can take a closer look to the mixture screw and how it works. By turning the screw, we open and close the fuel passage, therefore adjusting the ratio of fuel to air in the idle circuit. When we twist the throttle, the main jet doesn't start to deliver fuel right away. For a small amount of time, the idle jet is still the only source of fuel to the engine, which is why setting the mixture too lean or too rich will directly affect the responsiveness of the engine.